Hi guys, I have been using Honcho for my Hermes agent memory for close to 3 months now. And what I like the most is it remembers things about me. And I'm currently using Honcho in the cloud setup, but the problem is I'm going to run out of credits very soon. So in this video, I will be moving the entire memory setup to my machine and we will be covering what is Honcho, why I want to do the self-hosting setup and how does it work under the hood and how Honcho fits into this whole Hermes agent context. I will be showing you the live setup and after doing the setup, I'll be running it live. So this video is going to be power packed with information. Without any further ado, let's dive straight into it. Let's start with the basics. Let's first understand why Honcho and why I'm interested in self-hosting it. So to set some context, I have been using Hermes Agent for close to 3 months now. And when I started it, Honcho was the only external memory provider that existed. All the providers that you see now, Mem0, the one from ByteDance, Hindsight, all of these came later. So Honcho has been accumulating things about me and it models my working style. And I have been using Honcho on cloud, but the credits are running out. As you know, Honcho is open source. So I want to do this test. I want to take that memory, run it locally, and see if I don't have to pay for any of the hosting services. And there is a catch that I'll be covering about Honcho in the setup. So stay tuned for that. Let us take a look at what is Honcho. So Honcho is a memory infrastructure for AI agents built by Plastic Labs. Their pitch is continual learning for stateful agents, better context, fewer tokens. What that means in plain language is the AI agents get saved facts and a working model of the human it is talking to. Honcho calls that theory of mind and the core is open source, so you can self host it. There are two ways to use it. The first is managed at api.honcho.dev, and the second is self hosting it via the fast API server. And this is the one that we are going to do in the video. What I like the most about Honcho is the peer design. Like humans and the AI agents are treated like first class citizens. And in one session, there could be multiple participants. It could be a mixture of humans and AI agents and the messages are being exchanged. And Honcho does the reasoning over these messages so it can very easily answer the relationship questions that we have. Let us understand how Honcho works. So, Honcho adds a reasoning layer on top of search. After every conversation, it runs a dialect process. It asks itself questions about what the chat revealed about you. Then it drives conclusions, structured notes about your preferences and goals. And all of this built over time and it's running in a separate worker so that your main chat is not blocked. At the query time, what it does is it does a semantic search and adds a compact model of who you are. So the agent starts each turn with that context in place. Now let's take a look at the benchmarks published by the Honcho team. If you see on long mem s, it has scored 90.4% and on Locomo, it has scored 89.9%. If you are using a memory infra, memory quality is one thing that you care about along with fewer tokens. Before proceeding with the setup, let us take a look at how Honcho works with Hermes agent and where does it fit in. Understanding this well will make the setup a lot more easier for us. Let us start with the leftmost side, which is the Hermes agent. And Hermes agent has a built-in persistent memory. There are two files that make up the agent memory. One is memory.md file, and this is a agent's personal notes. It has facts about the environment, the conventions, and the things that agent has learned. And the other file is the user markdown file. And this is basically a user profile. It tells about users' preferences, communication style, and expectations. This persistent memory has this feature of session search and it is always active. Other than the persistent memory which is built in, the Hermes agent allows you to have an external memory provider. And in case you might be wondering why we need an external memory provider, the reason is as you can see, these two files that we have, they are small, there is a character limit to it, and they are curated by the agent itself. This persistent memory is good for stable nodes, such as your preferences, your environment details, your project details, and your past sessions, but it is not sufficient. And that's where the external memory providers come into picture. So as you can see here, for deeper persistent memory that goes beyond memory and user files, Hermes Agent ships with 8 external memory provider plugins, and one of them is Honcho. And these external providers are going to run alongside the built in memory. They are not going to replace the persistent memory. And they add capabilities like knowledge graphs, semantic search, automatic fact extraction, and cross session user modeling. So, in our case, Honcho is going to be this external memory provider for us. Another thing to note here is there can be only one external memory provider that can be active at a certain point of time. So Honcho allows us to add dialectic reasoning and deep user modeling on top of this persistent memory files that we have seen. As you can see on this page, these are the capabilities that Honcho adds on top of the built-in memory. And these are some of the pointers that we have already talked about. If you want to go deeper into this, feel free to have a look here. Now coming back to this diagram, so as you can see on the leftmost side, there is a user. User will send a message to the Hermes agent chat. And we have already seen this part where the Hermes agent have the built-in memory which it can always access. And in here, if the Honcho is active, then we have the Hermes Honcho plugin. So what happens here is when Honcho is active, Hermes will add the Honcho's context into the system prompt. Before each turn, it will prefetch it, and after the response, it will sync the conversation. The one that you see in the middle is the Honcho memory server. This whole box that you see, all these components together make up the Honcho memory server. And this Honcho API can read and write messages, sessions. It can search across sessions as well. And we have Postgres plus PG vector, and then we can optionally have Redis as cache, which is again an optional requirement. And here we have a Honcho API. This could be self-hosted, that is, it could be running locally on your machine, or you could be using the one that is hosted on cloud. So this Honcho API can read and write messages, it can write sessions and search across these sessions. The Honcho memory server side, we have something called a driver worker, and what they do is they turn all these sessions into observations, summaries, and conclusions. If we see on the rightmost side, we have something called reasoning model path. And this is something that gets accessed by this driver workers that are being running in the background that will do the conclusions and observations for us without blocking the main thread. And for reasoning, the Honcho needs to use some sort of LLM. So this could be an LLM from OpenAI, Anthropic, or Gemini, or this could be something that you are running locally. For this part, it depends on you, it depends on your hardware. One pointer regarding hardware, since we would be running this all locally. So this Honcho memory server is one aspect, and the other aspect is this reasoning model. And this memory server that we have seen comprises of the API, the Postgres, and Redis, which is light to run. So anybody can run it locally on their machine. But for running the LLM on your machine, you may require good hardware. So that is depending again on your configuration. If you wish, you can just run the memory server locally and still point to a cloud API key that might be cheap for you if that setup works well. But in my case, I will try to do the full setup locally. That means I will be running the memory server locally and also the model locally. Without any further ado, let's dive straight into the setup. Now let us look at the prerequisites that are required. So the number one and the most important is your Hermes agent should be up and running. If you are somebody who is new to Hermes, then you can directly download the desktop app or install it via the terminal. The installation is super easy. Next up, we need to have Git, we need to have Docker and Docker Compose. Number fourth is you need an LLM for reasoning. So this could be Anthropic key or the OpenAI API key if you want to run it on the cloud. But if you want the whole setup on your machine, then we will be running the model ourselves. And at the end, you need space on your machine to be able to run the memory server. Once you have all the prerequisites in place, we can now start with the live setup. And we will be following this quick start section that is going to use Docker. So first we will clone this repo for Honcho. So as you can see, we are cloning the Honcho repo. And after cloning, we are going into the Honcho directory. And in there, we have this docker compose.yaml file that we are copying. We are copying the environment file, and then we are running docker compose up. So as you can see, the repo has been cloned. It has created multiple containers. So one container is for Redis, the other is for database, the other one is for API, and then we have a driver one. And as you can see here, these are the different logs of different containers. And in the meantime, I want to walk you guys through the content of the Docker Compose file. If you see in the instructions that we have followed, we simply copied the contents of the Docker Compose YAML file and created this new file. So I'll walk you guys through this YAML file, and it's having four services as you can see. The first is the API, and it's running on port 8000, and the other one is the driver, and this one is dependent on cache and Postgres as we can see. Then the third one is the database, and this is the image that we are using. The fourth and the last is the Redis one. So all of these containers are being brought up when using Docker Compose. We also have Prometheus in here, which is for monitoring. If you want to use it, you can uncomment and it would be enabled. Now let us take at the other command that we followed. We copied the env file. So this is what the env files look like. It's for setting the environment variables, and the fields that are required are marked with required. So you can see the log level is info, and various other settings have been commented out. And this is the DB connection URI for PostgreSQL database with PG vector support. In the authentication, you can see we are not enabling authentication for this setup, but if you are running it in production, then you should set this to true along with a JWT token as well. And this is the section that is required to provide the LLM provider for reasoning, and it uses LLM for memory extraction, summarization, dialectic chat. And if we don't have this set up, then the server will fail to start. So it says if you want to use the built-in defaults, that we can set the OpenAI API key, the Anthropic API key, or the Gemini API key. And as we know, in my case, I'm interested in running this locally. So we would be using this setting where we would be using the Ollama route, and we would be overriding the model config model, and the model config overrides base URL. So you can see various other settings in here for the LLM. And yeah, that's pretty much how the env files look like. If you want to use a cloud LLM provider, fill in your API key here and then just run Docker Compose up. It should be enough for you. But in my case, I would be setting up a model locally. So let's do that. For running the LLM locally for reasoning, you need to have Ollama installed. So in my machine, I already have it. So I will type Ollama serve, and this should start the server. I want to see which all models do I have. So I'll do Ollama list. I just have Quen 3.527p. Now let's try to get OpenAI API compatible endpoint. So we will go to the Ollama serve, and here you can see it's listening on this IP address, which is local machine, and this is the port. So this slash v1 is going to be the endpoint that we will be using. As we have seen, Quen 3.5 is running locally on our machine via Ollama, and this is the model that we will be using for the Honcho reasoning. This we will leave as it is. So for the background worker, we will enable this. We will say the driver model config transport is OpenAI because Ollama supports the OpenAI compatible endpoints. And in the model, we will give the exact model name that we got from Ollama list. And then in the base URL, we are going to give the localhost URL where Ollama is running. And we are going to do the same activity for the dialectic. So let me quickly uncomment this, replace the model with Quen 3.5 and uncomment this as well. Now the next section is summary. We will do the same thing in here. Now for the dream, we will say Quen, and then for this one, we will say 127. Yep, this one. Then we will uncomment this OpenAI transport as well. And similarly for other settings if you want to do. After having done these changes in the .env file, we will stop the Docker Compose that was running earlier, and then we will run Docker Compose down. So all the Honcho related containers have been removed. Now we will run Docker Compose up -d dash build. So this is again bringing up all the 4 containers that we have seen earlier, but this time we will be pointing to a local model that is running on our machine using Ollama. Okay, so now the containers are up and healthy. We will run Docker Compose PS. We can see all the 4 containers and everything is showing healthy as of now. Then we will do a health check by using this curl command. We know that the API is running on port 8000, so we will say curl localhost :8000/health, and we got the status as okay. Now let's do a smoke test to see that the API database connections and the migrations are working fine. So we're going to use this curl command, and in here we are creating a workspace which is called test. So if everything is working fine, we will get the ID. So this workspace called test has been created in our local setup. As we have seen through this curl commands that the local setup for Honcho is working fine, now it is the time to connect Honcho to Hermes agent. So let's go to Hermes for that. So currently we are inside Hermes agent, and you can see the active provider is Honcho, and it is currently being done via the API key, that is through the one that is hosted Honcho onto cloud. And I want to point this Hermes agent to the local Honcho. So we will run Hermes memory setup. And in here, I have different options, as we have already seen, to choose from the memory provider. And I'm interested in number 4, which is Honcho. If you see till now, the choice is cloud because that's what I was running. And now I want to change it to local, which is self-hosted Honcho server. And this base URL looks good because this is where our API is running. And it's asking me for a local JWT token. I don't have it, so I'll leave it as blank. And this is my username, which is right. This is we can keep this as the AI peer name. And this is the workspace ID. I'm okay with it. And in the deployment shape, I'll select multi. And yeah, there are certain other questions that needs to be answered. The write frequency is async, and the context tokens is uncapped. I'll keep the reasoning level low. And as you can see, the testing connection is okay, and the memory provider is set to honcho in config.yaml. Here is the moment of truth to check if Hermes agent is actually using the local honcho setup. So let's say, hey, I want you to introduce me by my name, Nidhi, and talk to me in a friendly manner. And remember that whenever I tell you anything, I want you to cross check and verify before giving me an answer. If you see here in Hermes, it clearly says failed to save conclusion in Honcho. And so now I'm asking it why the conclusion has failed. Okay, so this one says the Honcho server is not running It says the connection is getting refused. And it says the config.json file has Honcho configured to connect to localhost 8000, but there's no Honcho server actually running there. I think I got the issue. So in my case, I'm running the local setup on my Mac, and my homies is running on Raspberry Pi, which is a separate IP address. That's why the local host is not recognizable on the Raspberry Pi, of course. So the cleanest solution to this is to update the base URL. We need to get the IP address of the Mac and then update the base URL to that particular IP address. Let me do that real quick. I've changed the Docker port mappings, and now in the Raspberry Pi, whenever I'm calling the health endpoint for the Honcho API, it's giving me status as okay, as you can see in the chat here. Now let's try to save a conclusion or a preference and see if it works. I've started a new session. Now let's tell it, hey, and can you address me with my name, Nidhi, every time you talk to me? Okay, so we found another issue. So what is happening is in my local, I've created the workspace called test, and Hermes is trying to hit this workspace called Hermes. That's why it's getting this 404 error. So what I'll do is I'll create this Hermes workspace on the Honcho server. So we are creating the Hermes workspace in the local Honcho setup. Now I'll say I've created the workspace called Hermes. Let us start a new session. Seems now in the local setup, it's creating the Nidhi peer, which is the human, and then it's creating the Hermes peer, which is the AI, because now it's able to find this workspace called Hermes. So now it is able to find the Hermes workspace, and it has created Nidhi and Hermes peer in that workspace, which says that the server returns 500 internal server error every time it tries to create a conclusion. Now, even after having created workspace and PO, why saving the conclusion is failing? Because we don't have embedding set in. So all these settings that you see for embedding are being commented out. So we will uncomment this, and this. And here we will add the Quen model, and here we will add in the localhost endpoint. I've changed the embeddings that will go through my local server. Now start a new session and let's test this again. So we'll have to restart the Docker containers again in order for it to pick in the new env variables. Now let's test it again. I'll start a new session in Hermes. Hey, will you remember to call me by my name, Nidhi, every time you talk to me? I know we are getting these errors again and again, and then we are going in this loop of fixing these errors. But that is the fun part of doing things live. So you know the issues that I'm facing and how I brainstorm and resolve it. Whew. So after debugging for a couple of hours, I finally figured out what was the root cause, why the conclusions were not getting created. So as we were able to see from the error message that for creating conclusions, embedding settings have to be enabled. And if you see here, earlier I was using Quen 3.5 for everything, but the issue is Quen 3.5 does not support vector embedding. So that's why it was failing. So I downloaded a model from Ollama that supports embedding. That is one part. The second part is you just can't download any embedding model. The model has to support 1536 dimensions. If it supports less dimensions, it won't work. So I tried a couple of models and some of them were below 1536 dimensions, so it was failing. So I finally figured out that Quen 3 embedding, the 4B variant, has this much dimensions. So this is what needs to be changed in the .env file. The other thing that I noticed is the localhost base URL is not going to work. So this is the URL that we need to use, host.docker.internal, and the port is 11435. I think earlier the port was something else. That was another issue. That is why the setup was not working. And yeah, the same thing needs to be changed. The base URL has to be kept this throughout for every section, let it be the background worker or the dialectic or the summary or even the dream section. So this is how your .env file will look like. And it took me a lot of time to figure out the exact settings. There are literally no resources available on the web that can help you with it. I even checked the Honcho documentation. It just talks about self-hosting, but it doesn't go into details of actually running the self-hosting setup via Ollama. So yeah, spend some time, but I think it is going to be fruitful to all of you. Now let me take you guys back to the terminal. So you can see here the Ollama serve is running. And if I type Ollama list, you can see that these are the two models that I have. I'm using Quen 3.5 27B for everything. And for embedding, I'm using Quen 3 embedding, the 4B variant. When you're picking an embedding model, make sure to check the dimensions. Otherwise, it can create a lot of failures for you. If we see here Docker Compose PS, the Docker containers are running, everything is healthy. Now I'm inside my Hermes agent and I will ask it to create some sort of conclusion for me. Hey, will you call me by my name, Nidhi, whenever I say you cutie? Let's see if the conclusion gets saved this time. Okay, so it seems the conclusion has worked this time and the memory has been updated. Now let me try one more test. So we will ask it, use the Honcho search tool to find anything you know about me. And this is one of the tools that the Honcho provides to the Hermes agent. It says pretty thin right now. It's basically a blank state. That's because I'm starting this from the local Honcho setup just like 15 minutes ago, and it doesn't have a lot of context about me. I want you to remember that I'm running this Hermes agent on a Raspberry Pi that was just lying around at my place, and now it's being actually used to run Hermes. Let's see if the conclusion gets saved now. It says it's saved in Honcho and saved in memory. Now let's use the Honcho search tool to let me know what you know about Raspberry Pi. I'm just cross-verify things here because I really want to show you guys that all of this, the Honcho memory is running locally and Hermes agent is being searching and concluding and accessing basically all these tools from the local setup that we are running on Docker on the Mac. So it says Nidhi runs Hermes on Raspberry Pi, which is actually right. And it said that's just the one conclusion that I have. So it seems it's working pretty well. Because I've faced a lot of challenges today, I spent close to 2-3 hours just to make this setup work. I wasn't aware it's going to take that much long, but clearly means that there are not a lot of resources out there to help you self-host Honcho using the local models using Ollama. So I'm going to push this repository that I have with all the configuration, all the environment variables onto my GitHub, and I'll link it in the description of the video. Make sure you check it out and you can just fork or clone it and run the setup easily so that you don't have to figure these things out. You can just save some time. That brings us to the end of this video. And this is the setup that I wanted to try for a very long time. And I'm glad I'm able to do it today along with you. So the Honcho memory is running on my local machine, and even the reasoning part is happening locally. So the whole setup is fully running on my Mac. And as you were able to see, the conclusions test was passing. That means the whole setup is verified and working fine. If you are somebody who is paying for a hosted memory provider, I would highly recommend you guys to try this setup first. I will make sure to put all the links in the description of the video, including my own repo with all the configuration and all the environment variables that I have used. If you find such type of content useful, make sure you subscribe to my channel and share it with your friend. It will help small creators like me to be consistent and to put more valuable content out there. Thank you so much for watching. I'll see you in the next one. Bye bye.